Go ahead, Brian.
Okay, anyway, so this is AP Calculus, Rolle's Theorem and Mean Value Theorem. So, now, it's, you guys got the packets on this one right here. For the Rolle's Theorem, Mean Value Theorem, it's all doing the first derivative. It's applications with your first derivative. So, if I'm looking here, I have, hopefully, there we go. So Rolle's theorem states that, I like red. Actually, you know, I'm going to do black. Okay. All right, so let f be the function, okay, be continuous on a closed interval. That's important. Continuous on a closed interval and differentiable. That means I could take the derivative at every point. At every point on the open interval, okay? Now, I'm going to take the derivative at every point on everything except for there and there, the endpoints, okay? So, if f of a is equal to f of b, then at least one number, okay, in C, one number C in AB such that the derivative is equal to 0. So, here's a picture of this. So that means that if they are both the same, that means somewhere in between, if it is continuous, that's somewhere in between there, I'm going to have a slope of 0. Yes?
Those would be our extremos?
That's what we're using this. So that's Rolle's theorem. So somewhere in between, I'm going to have a slope of 0.
Brick roll?
Okay? Yes? Edison, you had a question? Okay, just stretching? Okay. So find the two intercepts and show that somewhere here, some point between the two intercepts, so that the slope is equal to 0. So now first thing I'm going to do is set it equal to 0. Set the function equal to 0. Now if I'm going to set this function equal to 0, what do I have to do?
Find the derivative.
Say factor it.
I mean, F that.
Yeah, I have to F that, right? So I'm F'ing the F, not F the derivative.
A word?
F the F.
Yes, F the F.
X minus 2, X minus 1.
So x minus 2, x minus 1?
Yes.
Okay, so it's going to be x minus 2, x minus 1 is equal to 0, right?
Correct.
So where's the points?
Positive, X equals positive 2, and X equals positive
1 and 2, right?
Yeah.
Okay, cool.
1 and 2. So my points are going to be 1 and 2. So 1 and 2. Okay, so if I'm going back to this one right here, 1 and 2. Continuous in a closed interval here and here. Okay, differentiable somewhere in there on the open interval. Then at least one point there is going to have a slope equal 0. So, there we go. Okay. So now I have in between the here and here, somewhere in there, I'm going to have a slope equal to 0. Now to get the slope, I have to do the what?
Derivative.
Derivative. Take the derivative of that, so it's going to be f prime 2x minus 3. So f prime of x, right? Okay, set that equal to 0. So set that equals 0. So now it's going to be 0 equals to x minus 3. So x is
3 halves.
Ah, shite.
3 halves.
3 divided by 2.
Okay, so what does that mean? Very good. At 3 halves, which is in between here, my slope is going to be equal to 0. Yes?
Yes.
That's what I'm looking for. That's what I'm trying to get at. Does that make sense?
Yes.
Okay, it's just application. So this one is Rolle's theorem.
Cool. Small.
Okay, here's another one.
F dash.
F that boy.
Now, it gives you an interval here. Okay, so if I were to F this, if I F this, it's going to be,
X squared 2.
so x squared, and it's going to be x squared minus 2, right?
Yes.
Yes?
Yes, sir.
Okay, so it's going to be,
X equals 0. And
so
X
so right here, x equals 0, and x equals plus or minus,
2.
not 2,
Radical 2.
rad 2.
That's so rad.
Got him, coach.
That was a rad joke.
Okay, so
Okay.
now in that interval there, it gives us the interval here. So now for this right here, find this. So I have these, and now I also have to find the what? Find the derivative, right? That's what I'm trying to figure out too. Okay, so if I find the derivative, so my derivative is going to be 4x cubed, right? That's my f prime of x minus 4x.
So, yeah.
Okay, so what does that mean? Now I do what?
F out of X.
F out.
Oh, I'm sorry.
Okay,
Okay, so now 0 equals 4x cubed minus 4x.
4x times x minus 1.
What could I take out?
4x.
4x. 0 equals 4x quantity, x squared minus 1. So now it's going to be 0 equals 4x quantity, x plus 1, x minus 1. That looks like a lambda, sorry.
Lambda.
You are. Oh, you act that?
Okay, because that's the difference of squares, isn't it?
Yes, sir.
So that's the difference of squares, so I come up with what places in which that my derivative is going to be equal to 0.
X equals 0 and plus or minus 1.
So x equals 0 and plus or minus 1, right? So I have all the places in which that my derivative is going to be equal to 0, right? So are those in between my points on this interval here?
Yes.
Yes, they are. So we found all the ones that are in between my interval here. So from right here, do I'm finding them here? So from this one right here, is it still in between those?
Yeah.
Yeah, it is still in between those. So I found these, it's going to be in between. So my Rolle's theorem actually applies for this one because it's going to be between that.
Isn't rad 2 greater than positive 1?
Yes, it is because it's in between this, right? So if I'm looking at a number line, right?
But if rad...
So is it between this? Say yes.
Wait.
What if it was right?
Is what between
Are you
what?
talking about the
Which one is
X
in
that's
Which one are we putting in between stuff? Because
Okay, those are in between.
All these are between those.
Oh.
Because this one right here, I have this 0 right here,
I
so
thought you were saying
it's going to be
rad 2
between
was
those.
in
No.
between 0 and 1.
No.
I was about to say,
So this is my interval, so it still applies here. So that I have my interval here, that's somewhere between here, that it's going to be these. These are the places in which that it's going to have those.
So you have multiple intervals?
Yeah. So I could have multiple intervals, but because this one right here,
that narrows down the search.
yeah, so in between here and here, I have it at 0. So from 0 to, from negative rad 2 to 0, I am going to get one of these, right? Okay. And from 0 to positive rad 2, I'm going to have another one of these. But now, right here, this is going to be 0 and 0. So I have a slope at 0. So what is it going to look like if I have my function equal to 0 at 0, and my slope is equal to 0 at 0? It's going to be a min or max, right? So it's either going to go up to 0 at that point, or it's going to go down to 0 at that point, and only touch it once, and then go back.
It's going to be a quick bounce.
But being an x to the 4th, and that x to the 4th is positive, isn't it? So yes.
Yes.
Okay, so x to the 4th. Now, what do you think the function of x to the 4th is going to look like? Let's use the arms. Which arms look like? Like this? Or is it like this?
It was good.
It's like this. It's good?
Can it be like this?
It's good. Nope. Why is it not like that?
Positive.
Positive, so it has to open up.
I'm asking, can it be like that?
Huh?
There's a possibility.
If it's a negative, yeah.
If there's a negative x here,
I don't
if
think
there's a
positive
negative in
is
front, then it would. But because of that, it's going to go.
It's not reversible.
It's gonna go like a big fat dove.
Big fat dove.
It's a big fat dove.
So something like this. So at 0, it's coming up right here, and it's touching it at a single point. And at -1, I have a slope of 0 here, and at +1, I have a slope of 0 here. So here's
There's the quick bounce we were talking about.
right.
Wait.
Yes.
So which interval matters? Both of them?
Okay, this one, it gives you one that's greater than this. So it's asking, it says find all values of C in this interval. So using Rolle's theorem, first thing I did, I went through and found those. Okay, so that means that I'm going to have some that are inside this, that apply to Rolle's theorem. They just gave you bigger bounds.
Oh,
They gave you bigger bounds, so you're not using rads on that one. Okay, and so these ones are your points in between. So those are your C values right there, in which that your slope is equal to 0.
Wait, real quick.
Yes.
So the final answer is written as the interval negative.
Those are your intervals, yes. Your C values.
Could they be bigger than the bounds?
Nope. Because it's got to be between them, right?
Could it be the same
If
size
they
as the
were,
box?
would you exclude them?
Yes, I would exclude them if it's outside my interval.
What if,
Because I'm only looking at things inside of this.
could it be the same size as the box?
No, because can I include those?
No.
Why can I not include those?
Parentheses. It's
Parentheses, there we go.
If they in brackets, then we can.
Okay, so now let's go back to what did Rolle's theorem say?
Never mind, yeah. My bad,
He
my
just
bad.
didn't want to.
My bad.
Okay, alright, you're bad, you're bad.
You're bad.
My bad.
Okay, I think it's your bad.
My
Alright,
bad.
you guys got practice problems on these?
Say swear.
Oh,
Practice.
Talking about practice?
Okay, so, mean value theorem. So if f is continuous, continuous is the key word here. That means it has to have no holes, no jumps, no leaps.
No kinks.
Yes, okay.
What?
On the closed interval, a to b, and is differentiable, so that means you have to be able to take a derivative at all points in between a and b, then there exists a number c that AB, in AB such that the slope is equal to something, the secant. C average, right? It's basically the secant of your endpoints there, right? So what it means is, even if it is going up or down, at some place in there, it's going to be equal to the average. Okay?
So in the interval, there's a point in the interval where the y value is equal to the average of the whole thing?
Yes. Okay? It might be at some point greater than, it might at some points be less than, but the average of the slope is going to be somewhere in there. So you're basically using your endpoints to find the average, and instead of setting it equal to 0,
Set it
Okay.
equal to the average?
set it equal to the average. So you're trying to find your points in which that you're equal to the average. Does that make sense?
That's very enlightening.
Okay. So here, let's see if this one actually makes a little bit more sense.
We had it.
Let me use this analogy.
Crossing the road, oh my god.
Until it gets
All right.
Finally it finds use.
Based on negative.
So
That's a chicken nugget.
now it starts here, it ends here.
McDonald's.
This is the graph of the slope of this one right here, right? So I'm gonna somewhere it has to cross, doesn't it? It has to cross somewhere. It has to eventually have a slope that's gonna be equal to the average.
So it has to cross.
So
somewhere.
if you notice, I have this much above and I have this much below. So the road is my average. Yes.
Since it has to cross somewhere, does that mean you can graph both? Like if you're taking a test, you can graph both, and then use just look at the point where they cross, and then you find that value.
So if you found the slope, and you're okay. So I think I know what you're going. So if you, let's say the slope is 1/2. Okay. So graph 1/2. So you'll have a line at 1/2, and then you graph your derivative and see where your derivative is equal to 1/2. Is that what you're saying? Yes, you could do that using a graph. So you can graph that. So at some point it's going to equal that. Okay? It might from this point shoot straight up and then, you know, go down from here, but the average is going to end up what the road is. So I've been waiting all year to use this analogy. So chicken crossing the road. Now, let's take a look. For this function, find all values of c in the open interval such that blah, 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 blah. So what does that mean? What's that mean? Find the average, right?
Yes.
Okay, so it's basically the secant line through there. So what are we going to come up with? So
You plug in
f of 4 is what?
is 4.
4.
So it's 4 minus
1.
So
1 all over 3.
so it's going to be
So it's 1.
4 minus
1
1 over,
4 minus 1.
which is
1.
1.
Now we have to find out
So
prime of C.
f prime c has to equal 1, right?
Yep.
So now, so let's take the derivative
Instead of equal to 1.
and set it equal to 1. Okay, so that's what we're doing.
Now-
So now it's going to be, so f prime of x is equal to, now,
5 plus
nope, take the derivative. What happens to the 5?
It goes away.
It disappears.
It goes away. It goes away.
4 times
over
negative
x
1.
squared.
Okay, so it's going to be,
Negative 4x to the negative second.
No,
No, wait.
because
Wouldn't it be
wouldn't it be just be 4 over x squared?
4 over x squared. It is going to be 4 over x squared because if I move this up, right?
Wait, is it
No.
negative?
So if I move it up, so if it's 5 minus
Sorry to cut you off.
4x to the negative 1, is that better?
That's what I
Is that better, doing it like that? Because this goes up front and it makes it a positive, right? And then I have to subtract 1 from my exponent. Yes? So it's going to become, that goes away,
Positive.
positive 4 over x squared.
4x squared.
Okay, so what am I doing now?
Set equal to 1.
Set
Set
this
it
equal to
equal to
1.
1.
So
Or,
1
no,
is
set
equal to,
f prime c actually.
yeah.
So you don't confuse.
So right here, so it's going to be 1 is equal to 4 over x squared. Multiply both sides by
X squared.
x squared. So I get x squared is equal to 4. So x equals plus or minus
Deuce.
2.
Yay.
So I have two places in which that this function is equal to the average. So the slope is equal to the average at two different places here. Now, let's can I exclude any of those?
No.
Then
No?
Yeah, negative,
Yes?
Negative 2.
It's outside.
Why?
Because it's outside the interval.
It is outside your interval right here.
wait, two
Got it.
places where the slope is equal to the average.
Yes. Two places where it's equal to the average, right? Like I have here, but then I go back to what I have here. Find all values of c in the open interval from 1 to 4. So now, one of those is outside of my interval.
Negative.
Yep, so it's just going to be x equals 2. Or c equals 2. Whatever I want to do for that one.
A T U
Does that make sense?
Yeah.
Yes?
2 thumbs up from this guy.
V Z